Alright, let's look at practice exam 2, problem number 1. Alright, so we have inverted cone-shaped tank, water tank, with a height of 9 feet, and the radius of the top is 6 feet. Right, drained through a hole in the vertex, so you can see that the water is coming from the bottom like this. Right, at the rate of 4 cubic feet per second. Then we want to find the rate of change of the water depth. So we decided to call, let's call that water depth y, because it's a vertical distance, y, when the water depth is equal to 5. So at this point, it's 5. Right? So let's do that. So we have to come up with the equation that relates the volume of the water and also the depth. Right? So let's write the volume of the cone. So volume of the cone would be V is equal to 1/3 pi radius squared times height. Right? Then when you look at it, let's see, so 1/3 pi, so I'm going to just write it as a pi over 3. Right? So what is the radius? Right? So radius is sitting right here, so I guess we can call this guy r right here. And you have to find express this r in terms of y. Right? So I pull out this big right triangle and this little triangle, so I drew it here, and those guys are similar triangles because you have the right angle here and these angles are shared, right? So angle angle, maybe I should write angle angle, tells you that these are similar triangle. So we can do the ratio between corresponding sides. All right, look at the ratio here. It's 6 to 9, right, or 2 to 3. So if this ratio r to y is 2 to 3, so r is same thing as, maybe we should write it as r over y is same thing as 6 over 9, which is 2/3. Right? Then you can just multiply both sides by y to get the r is really the same thing as 2/3 times y. Alright, so we found that the r can be expressed as 2/3 y. Then you have to square that. Right? Alright, height of this the cone is y, so we can just put y. Alright, so let's clean that up. So you're going to get, let's see, 2 squares, so 4. So you have 4 pi on top. You have 3 and 3 squares, so 3 times 9 is 27 on the bottom. Alright, then y squared, another y, so there's y cubed. Alright, and what else is given? Let's see, so we have, it's a rate of change of the volume is given, so we know that dV over dt, right, is equal to, since it's draining, it's actually -4 will be the rate of change there. And also here, water depths at this moment, water depth is equal to 5 feet. So which means that the y equals 5 at this point. Right? Then what we're looking for is, what is the rate of change of the water depth? So we're looking for dy over dt. Right? Alright, so since we're looking for dy over dt, we should probably take the derivative with respect to t. So let's go ahead and do that. Right, so take the derivative of volume with respect to t. So we have dv over dt is equal to, right, 4 pi over 27 is just a number. So we just write it down. So 4 pi over 27, right? Then derivative of that would be 3 in front, y squared, but you would have to multiply by dy over dt because of the chain rule. Alright, then we can clean that up a little bit. So you have 3 and a 27 cancel out, then you have a 9 left over. Right, then you will get 4 pi over 9 y squared and dy over dt. Alright, so we can see that this is what we are looking for. So this is what we are looking for here, right? So this is the guy we want. And it seems like we know everything else. You can see that we know y is 5, so we know that. This is just a number. And dv over dt, we already know it's -4. Right, so put everything in. Right, dv over dt is -4, so I put that in here. Right, then you have a constant here, so 4 pi over 9. Right, y is equal to 5, so we put that in here, so 5 squared. Right, then we're looking for dy over dt. Right, so we just have to solve for this. Right, so first thing is I would probably divide through by 4, because you can see 4 in both sides. So I'm going to cancel that, divide by 4 and divide by 4. Right, then we can just let's see, multiply. We have to get rid of this guy right here. Right, so we're going to multiply by 9 to get rid of the 9 on the bottom, and divide by this is 25 pi, so over 25 pi. Right, so this is going to be negative 9 over 25 pi is equal to dy over dt. Right, so what is the rate of change of water depth when it's, alright, so rate of change would be, so therefore it's a negative 9 over 25 pi. Alright, so this is going to be feet per second. Right, so that's how fast the water depth is changing. Right, that's it. I hope that this was clear.